So today we're doing another CodingBat problem called array3, and this is called canBalance. So given a non-empty array, return true if there's a place to split the array so that the sum of the numbers on one side is essentially equal to the sum of the numbers on the other side. Now, this is definitely a very confusing problem statement. Actually, when I first read the problem statement, initially I thought that, and actually let me zoom in here. Initially, I thought that if we had an array like we have here, I essentially thought, okay, well, I'm essentially given an odd array, and I want to find the midpoint of the array, and essentially the midpoint, if we were to judge here, the midpoint of, let's say, this array would be here, which would actually be nums.length minus 1 over 2, which would give me this position. And then I was going to judge, so I was going to add all the elements from to the right and all the elements to the left, and then store them in their own variables, and then compare if those variables are equal to each other. But it seems as though this question is actually not asking you to essentially do that. It's not asking you to find a midpoint. In fact, with that assumption, with the assumption of saying that, okay, there's a midpoint and that the numbers to the left, or right rather, should be equivalent to the numbers to the right, the sum that is. With this notion, I came across this test case doing this problem, and there was this test case for 1, 1, 1, right? And actually, I think there was one more one, yeah. And so this was the test case. Now, operating under the previous assumption that we had, that is to say, the assumption which sort of followed the fact that we would have a midpoint, which in this case is 1, and the numbers to the right summed must be equivalent to the numbers summed, which are to the left. And so on the left here we have 5, and then on the right we have 2. And so since those numbers don't match, we essentially return false. But that's not what the question is asking. The question is saying that if at any given point the numbers to the right are equal to the numbers to the left, that is to say, at any given point, if the numbers to one side are equal to the numbers on the other side, return true. And so this is what they meant. What they meant was, okay, so you'll see that as I'm looking through the array, and I'm saying, okay, what you notice is that you have 4 ones on one side, and you have 1 4 on the other side. And so this constitutes as being an array which fits the classification for this question. And that was confusing, right? I mean, you'd think that, okay, to the left and to the right, and since they're both odd arrays, I don't know, I'm not too sure what we do for this case, but maybe a special if nums.length is less than or equal to 2, something like that. But for this question, we really want to figure out if I were given, let's say 4 and 2 and 5 and let's say 3, or actually 2, right? So this is or actually let me just do 1. Oops. So on one side we have 6, and on the other side we have 6, and so this constitutes as a successful array which fits the classification. But of course it could be like this. It could be 1 1 1 1, right? It could just be like this, where we have this is equal to 5 and this is equal to 5 as well, and so we now again have an array which fits the classification. So this is the type of arrays that are really meant to be evaluated here, and this is the classification which we actually want to look for. Now, so how do I do this? I was completely flabbergasted. I didn't know how to do it, and I thought to myself, okay, well, if I had, let's say, if I had something that looks like maybe it looks like this, right? So we have 4 on this side, okay, and you have 4 on this side. So I thought, okay, let me start by looking at the first element. Let me look at nums of I, and actually let me type this out. Look at nums of I, right? And then store nums of I in a variable. Okay, that's the first step. And then look at each and every single element after that and actually sum those up. Sum all elements after nums of I and sum those up. Does that make sense? So we look at the first element, right? And then we look at all the other elements and oops, and then we see if the sum of these elements is equal to nums of I. And so our first problem here, our stepping stone as to actually finding a solution, is firstly that is to check the first number and then to check all the other numbers and see if that number, in fact, if those numbers, if the sum of that addition is equal to nums of I, then we'll return true, right? But of course, there are other parts to this which are perhaps a little more engaging, right? Which aren't as simple. Like for instance, we could have something like this, right? So we have something like we have 4 and 2, and we had, let's say, 2 and 4, right? So in this case here, it's not, we're not, so if we were to do the same assessment, if we were to look at nums of I and look at all the other numbers after, add those up, we get 4 plus 2, we get 4 plus 2, which is 6, and then plus 2 more, which is 7, 8. And so we have 4 on one side, 8 on one side. That just doesn't match up. So nums of I does not equal to the sum of the elements which come after nums of I. However, this still constitutes as a true array fitting the classification which the question has put forth. And that's because we have numbers on one side which are equivalent to numbers on the other side. And so we can split the array right down the middle. Here, we could split the array when we had 1, 1, and then there was a 1 here as well. When we had 1, 1, 1, and 1, we could in fact split the array right at this point. They were balanced at this point. So first, I want to sort of talk about how we can actually find whether or not nums of I, which is this, the first element in the array, is equal to all the elements, the sum of all the elements in the array which come after nums of I, which is the first element in the array. And then we'll talk about making adjustments to that notion, to that code, really, and then hopefully fulfill the requirement, which is a little more dynamic. So the first thing I'm going to do here is I'm going to go to IntelliJ, and so what we're going to start by doing is we're going to have a test case, right? And so let's go ahead and actually let me make sure that I'm sharing this. So let's go ahead and first have a test case. So that'd be something like nums, right? And that would equal, let's say, 4, 1, 1, and 1, and 1. Maybe something that returns true. And so we know for a fact that nums of I is in fact equal to all the other elements in the array added to each other. And what we'll do from here is we'll actually bring in a for loop, right? And because we want to iterate through the array to actually, and I'll tell you why we want to iterate through. We want to iterate through because we want to add all the elements. We want to add all these elements. And my approach here is really to have a for loop, an overarching for loop, and I guess we can call this overarching, right? And essentially what this is going to do is it's going to add all the other elements, besides the first element. Okay, and once it does that, once it stores that that addition, or let's say once it stores that sum into a variable, we will compare if nums of I, which is of course the first element in the array, if nums of I is equal to, and I think, yeah, if nums of I is equal to that sum, right? And that's how we make that comparison. So, I mean, really, when it comes down to it, if this comes down to 4 and this is 4, right? Or we could have another one. We could say, if this is 3, right? And then we have 1, 2, 3. And so if what's here comes down to 3 and this is 3, if the first element, if the sum of all the elements which come after the first element, if that is in fact equal to 3, or equal to the first element rather, then we have an array which fits the classification. So I wanted to add all the elements besides the first element. So I thought, okay, let me use a for loop. Let me use a for loop, and I'm not going to start the for loop at 1. In fact, I'll have to change the letter which the for loop has as a variable. And so we're going to start from 1, and k should be less than nums.length because we want to actually go through the entire array. and we'll increment k by 1 each time. Does that sound good? And so this actually allows me to do something to all the other elements besides the first element. And what I can do here is I can actually have an integer variable called sum, and I'll set that equal to 0. And what I'll do in here is I'll use the accumulator pattern. Sum is equal to sum plus nums of k. And so each and every nums of k that I encounter will be added onto this accumulator, and it will essentially just keep adding onto itself and present the sum. Now I could use the shorthand method, something that looks like this, right? But I guess I'll just stick to this for simplicity's sake. And so moving on, right? So now we're just assuming that we have the sum, and we've stored the sum into a variable, right? And which is called sum, which we have here, and we'll compare if nums of I is equal to sum. So we'll say if nums of I is equal to sum, then essentially what we're going to do in this case, we are going to, well, let's have maybe a Boolean, right? Maybe something that could, since we can't return true, it's not a method in and of itself. Why don't we just have a Boolean which is equal? Maybe is that we'll set that to false to begin with, and if this condition is satisfied, we'll set it to true. And so we'll say that if nums of I is in fact equal to the sum, then is equal is set to true. Okay. And since, of course, our test case does in fact fit the classification of the array for which we'd want to return true, then this one should return true if we print out true after the for loop ends. And you'll see that it does return true, right? So we could have a similar pattern. So let's go ahead and try doing something else here. Let's do 6, 3, and 3, right? And this should return true, right? And the first element does in fact equal the sum of all the other elements in the array. And actually, I can't reach my wow. 1 second here. So now when we run this, actually, it seems like we must have deleted the sum variable in sum. And so we still get true. And so you can see that this works, but this is problematic. It's problematic because we come back to that other case. And that other case was something that looks like this. Now, we'd want to return true because we know that the sum of the elements on one side is equal to the sum of the elements on the other side. That is to say 4 plus 2 is 6 on one end, and 4 plus 2 is 6 on the other end. And I mean, we could have another example. We could say 5 and 3, right? And that is equal to 8. And if we were to do 4 and 4 on this side, that too is equal to 8. And so we have this other relationship here where we have different numbers, but we have the same pattern. So we have numbers which is equal to a particular sum on one side, and the same sum can be found adding some numbers on the other side. And we could do something like this as well. And this would still count. This is where the breakpoint would be. It would be here, and it would be here. And so I mean, that's really what we're not going to get. So if we do 4, 2, and 4 and 2, we're actually not going to get true as much as we hope, right? And so we do get true miraculously for some reason. Not too sure why that's the case though. Interesting. So we get 4 plus 2 is equal to, well, we get 4, and it's not in fact. Okay, so we're always returning true, it seems. We want to return is equal, not true, of course. And you'll see that this one gives false. And if we have a proper case, which looks like this, then we get then I believe we would get false in that case. So, or actually we would need a proper case, right? So 4 on one side, 4 on the other side. So we'd get true, right? So just don't do that, right, to test your program. But so if you think about it, so this is the way that I thought about it. I said, okay, well, first I'm going to look at this element, right, and then I'm going to look at all the others and sum them up and see if it's equal to the first element. And then I'll look at the second element in conjunction to the first and add those up and see if it's equal to the sum of the elements on the other side. And what I'm saying could sound pretty confusing, but let me go through it, right? So on my first iteration, I'm gonna judge whether this is equal to, and I don't think this is being shown. So in my first iteration, I'm going to judge whether this is essentially equal to all of this, right? The sum, that is. So this has a sum, okay? And this has a sum. Well, I guess I'll call this sum 2. And so I want to judge whether the sum of this is equal to the sum of this. If it's not, then I'll check the second. I'll do this pattern again. I'll do this in conjunction to checking the sum of 4 plus 1 now. I'll check the rest, right? So does this sum equal to this sum? And then I'll go again. And I'll check, okay, if it's not, then does the sum of these 3 numbers equal to this? If it's not, then do the sum of these 4 numbers equal to this, right? To the sum, that is. And so it's like this. If you want to visualize it a little bit, we can zoom in here. And so this is how the algorithm would act if it were sort of moving, right? So first, on the first iteration, it would check all these numbers and judge whether the sum, which is 4 here, is equal to the sum of these numbers. And then and if it's not, then we'll move on, right? We'll say, okay, so this was like the first one, right? And then we moved on, and we said, okay, well, this was the first one, and then we moved on, and then we said, okay, does 4 plus 1 equal to the sum of all this, right? And that's 5, and that's 3, so no. And then we moved on, and we said, okay, does the sum of all this equal to this, or does the sum of all this equal to this? And so we have this growing pattern here, just like this. It's like this growing pattern. You can see it. First, we're checking all of them. And we're saying, okay, does the sum of this equal to all this? And then the third time, does the sum of this equal to all of this? And then the fourth time, does the sum of this equal to all of this? And then the fifth time, does the sum of this equal to this, right? So you get the point. And I mean, so the problem with the program that we have now, which seems to have disappeared on us, which you can actually see, that's pretty crazy. You can actually just hover your mouse over and you can actually see exactly what's inside there. But I think if we do control, does that not open anymore? I'll just do this, yeah. So so this is a problem, right? Because we're static. We're always only checking the first and the rest. We're not checking the second and the rest, or the third and the rest, or the fourth and the rest. We're only checking the first. And so, because of course k starts from 1. So if k were to change, if it were to be dynamic on every iteration, if k were to represent the next thing that we want to look at, let's say this one, right? And then this one, and then this one, that would make more sense. So on the first iteration, we just look at this and we check if the sum of that is equal to all the other elements. If it's not, then we start from this one and we check if all these elements are equal to this. And then if it's not, then we start at this one and we check if all these other elements are equal to this, right? Or rather equal to the sum of every single element which came before, because that's the only way we can actually have a sum on one side and the sum on the other side, which actually adds up to that's the only way we can compare both sums. So we wanted to make this dynamic. So what we did was we automated this out. We said this is going to be index. And index doesn't actually exist, so we're going to have to bring it into existence. We're going to have int index. And essentially what's going to happen here is, if you notice, we're actually not, for the first iteration, we look at the first element, but we look at the rest, right? So we look at the first element, but we don't start adding from the first element. We start adding from all the elements which are after the first element. Similarly, when we're on the second iteration, which is actually at the first index, so I is equal to 1, we start looking at everything that is after the 1. We start adding those elements which are after the 1, and then we compare it to this element. And so we're not actually starting from here. We're actually starting from here. The for loop, which is supposed to add these things, are actually starting from here. And similar, when we're on here, we're actually not looking at this one. We're looking at this one as to compare the sum of this to this, but we're not so much as actually including this number in the sum. And so we start from one lagged in sort of the future, so to speak. So it's lagged in the future. So we start here, and then we start here, but we're actually starting here. And so we say, okay, this index is it's not going to start from I equals 0. It's going to start from I equals 0 plus 1. And it's going to do that each time for every single index that we pass. It's going to only consider all the other elements 1 to the right of it. And so that's really the thought process there, is 1 to the right. And as we move on here, what we want to end up doing is, so let's try to, and I'll show you why this is problematic, but let me try to actually print out the sum of all those elements, right? So actually, I don't think I can do that because it's in a for loop. But what you'll notice is that if we go through the iterations here, so if we go, so on the first index, when I is equal to 4, we come down here and we say, okay, index k is equal to index plus 1, so we're actually starting at the first element, and then we iterate through the rest of the entire array, and we add this. We have an accumulator pattern to give us the sum, and I mean, that works. And then in the second time we do this, k is equal to index plus 1, k is 0, and we start again from the same exact index. That doesn't make a lot of sense. We want to have some means by which we can actually increment the index, so that we can actually look at a different element each time the for loop runs. And so we do index plus plus to actually add 1 to index, so that the next time this for loop is triggered, it actually starts from 1 more than what it was the previous time. And so that's really the reasoning behind that. And so yeah, so now we're moving along, right? We're moving along and we're storing those sums. And what we can do now is, well, let me try to print out. Let me try to print out the sum. See if I can make out some of the logic here visually on the console. So you'll see that I have 10. Now, what is this 10 saying? So we start from here and then we add up all these elements, right? And so we have 1, 2, 3, 4. And the second iteration that we're on, we go here, right? We're starting from this one, but we're actually starting from here. So 4, 5, 6, 7. And then when we're here, we start from here, 8, 9. And then when we're here, we start from here, and then we get 10. So we are moving through the array in that pattern, in the pattern that I just discussed before, which kind of goes like this. Or you can think of it as like a dying flame, which is reignited every so often. So it goes from here, and then, and then here, and then here, and then here, and then here. So we're doing that. And then we say, okay, if nums of I is equal to sum is true, right? And we know that this should give us true, right? Because, I mean, it should. And so when we do is equal, we should get true, right? Because it fits that case. But does it fit it for this case? No, it doesn't, although it should, but it doesn't. Does it fit it for 4 plus 1 or 4, 1, 1, and then let's say 6? Should it? It doesn't, but it should. So 4 plus 1 is 5, plus 1 is 6. And so at this point here, the elements on the left, or the right rather, are equal, or you could say the left. The elements on the left are equal to the elements on the right. So it should for these cases, but why isn't it? Because all this program is doing, this entire program, all it's doing is it's checking the first element, adding all the other elements that are sort of to the right of that element, and it's adding them and it's comparing them to the first element, which is nums of I, right? And I mean, that's really the issue here. It's not considering. I mean, if we move downward through the array to the right, we want to also consider all the elements which came before it, like I discussed before. So saying nums of I is equal to sum, that's just taking one element at a time. That's just taking the nums of I that we're on. And so what we do is we can add, so we actually have to take, so when we're here, we want to have the sum of this and compare it to the sum of all the other elements which come after. And so when we're here, we want to have the sum of this and then compare it to all the other elements which come after, which is 6. And so we want to constantly add, we want to have an accumulator pattern for nums of I. And so we'll have int sum of elements maybe equals 0. And then we'll have a little element accumulator here. Sum of elements equals sum of elements plus I maybe, or not I, nums of I, right? Because it's not nums of k. Nums of k was for the adding the other elements. Nums of I is the current iteration that we're on. And yeah, and so then we would check if sums of, or if the sum of elements is equal to the sum of all the other numbers. And then that would allow us, I believe, to return true for something like this, which we're actually returning false. So let's see what's going on here, right? So sum is equal to sum plus nums of k. Sum of the elements is equal to sum of elements before plus nums of I. And then, of course, we increment the index just so that we start off from a new element. And if the sum of the elements is equal to the sum, then is equal to true. Otherwise, is equal to false. So 4, 5, 6, and then 6 is here as well. So it seems like, I mean, let me try another case here. Is it just only this case? So this one also gives us false, which is pretty weird. Sum is equal to sum plus k. Sum of elements equal sum of elements plus nums of I. And that's sort of like the accumulator for nums of I. And then we check if nums of elements is equal to nums of elements. So what's actually happening here, and if we look through this, the sum for the numbers, right? So if we think about the sum for the numbers, while we're moving, we're adding each nums of k to the sum. And it does that. It does that for, let's say, so as we're moving, we have the sum of all these elements. That's fine. And then on our second iteration, we have the sum of all these elements. But it's not actually the sum of all these elements. It's actually the sum of all the elements that we had before, the sum we had before, plus the sum of all those elements. It's carrying on the value of sum because it's a sort of a class variable. It's a global variable. It's applicable everywhere. And so we want to reset the value of sum each and every time we come in the for loop, right? And so we can declare int sum equal up here, and we'll set it equal to 0 here, because essentially we want to reset it each and every time we calculate a new sum so that it doesn't carry over what it had sort of before. And so when we do that, we should get true for something like this, right? And when we do the example that we had before, something that looks like this, we should get true for this as well. And I think, okay, so let me try 4, 4, 4, and then 16, or actually 4 plus 4 is 8, 8, 9, 10, 11, 12, so maybe it's 12. Okay, great. So, so this should work if we were to sort of put it into CodingBat, right? And we'd actually want to return is equal